Hey everybody, the purpose of this video is to walk you through the mighty central limit theorems quiz. This is a review quiz for the most part. I know that those of you that had me in 243, it was the last thing we did in the last week of the term. We spent those last 2 days, and really if you think about it, the last day of the class was spent on the theorem itself. There wasn't much in the theorem. It seemed like there was because it took us 2 days to kind of arrive at the result, but honestly we didn't spend a whole lot of time other than those 2 days, which is kind of comical to say because that's 10% of a class, but nonetheless, it didn't seem like it was a whole lot of time because we didn't have that time to revisit over and over again like we often do in this course. But that's okay, because we will revisit this idea over and over again in 244. Anyway, I described the population to you, of which you will never see. Average of 23, sigma of 4, and you'll never know either of those things. You draw a sample of size 100 from the population. Okay, so you know the population. Actually, you don't know this, but out in the population, you've got an average of 23 and a sigma of 4. And that's out there. I mean, you have no idea of that, but it's out there, and your sample is governed by that. So your sample is going to have a size of 100. And the first thing I want to ask about is, let's talk about this sample. What is its average going to be ish? And I put ish on there. What its approximate average be? Well, we learned back in 243, and you guys picked this up right away, that it doesn't matter what the shape of this I said it was a highly skewed population. It doesn't even matter that it's highly skewed, because you know the sampling distribution of the average of all the possible sample means, the x bar, x double bar, is going to be the same as mu. It targets it on average. On average, you get mu targeted in your sample, on average. Of course, there's variation around that because it's a sample of the entire population, but you're going to target it on average. The kicker is, if that's the average, what's the standard error, which is the inferential measure of the sample standard deviation? Well, we discovered back in 243, in that last 2 days we were together, that it's equal to the population standard deviation divided by the square root of the sample size. So in this case, it's 4 over, what is that, 10 or 0.4? Or 0.4, which is fantastic. That's super fantastic, because your standard error has to shrink as your sample size goes up. That's why when you see studies that have been done for years and years and years, for example, I'm looking at pictures of my son right now on my wall, average height of a 5.5-year-old white American male, average weight of a 1.5-year-old white American male. I mean, we're talking about tens and thousands, if not hundreds of thousands of data points. Your standard error shrinks down to nothing. If the population standard deviation is something like 2 pounds, I mean, essentially, you're not going to have any standard error. So you can report as your data points as the population. So just we've discussed that ad nauseum in 243. I skipped over part A. It says your sample's average is part of a sampling distribution. It's going to be bell-shaped. We also discovered that. That's the trickiest part of the theorem to prove. I do have a proof online if you're interested in seeing it, but it is a bell shape. It's a consequence of the behavior of the data. So pretty slick, actually. The last part, it says, based on your previous 3 answers, I asked for approximately 95% of your potential sampling averages and 99.7%. Now those percentages should ring a bell to you. Not to make a terrible joke, but okay, your average is going to be a 23 for both of them. 95, let's pretend I'm drawing this somewhat correctly, and 99.7 are the endpoints of 2 and 3 standard deviations, or in this case 2 and 3 standard errors, which is interchangeable as far as the areas go. Definitely contextually different, but interchangeable as far as the area goes. So 23 down 2 standard errors is going to be down 0.8, which will be 22.2. And up 0.8 will be up to 23.8. Now, I know I asked you to show me work on this, so what you'd have to essentially do is, I just verbally said it to you, up and down 2 standard deviations. You'd have to either write down that or write down 23 minus 2 times 0.4 and 23 plus 2 times 0.4, either choice. So here's your 95% interval for averages in the sampling distribution. And your 99.7 would just be 0.4 more on either side. So 0.4 more up from this would be what, 24.2? Let's make that with a different color. 24.2. I hope you can see that, 24.2. And then down 0.4 would be 21.8. A little bit wider. And that should be a little bit wider because you're including more averages, so you have to go out wider to catch them. So there you go. Quick, easy set of solutions for your first, or I guess your second, whatever, third, whatever quiz this is for you. It could be your first quiz. But don't worry about memorizing this kind of stuff. You're going to see it over and over again starting next class. And we've already seen it a couple times, so we'll catch you then.